In part 4 of section 16, we're going to discuss the concept of discontinuities of a rational function. Now, we've already seen one example of a discontinuity when we were graphing the parent functions, the reciprocal and the reciprocal squaring function. Those each had a vertical asymptote. The vertical asymptote is a type of discontinuity, and you can think of discontinuities as being breaks in the graph. And so that break in the graph caused us to have to make two different curves, but both of the curves together actually represent the entire function. But the vertical asymptote is not the only type of break that you can have in a graph. You can also have something called a hole. So we will discuss these two types of discontinuities. Definition 16.2 is going to help describe how you can tell the difference between the vertical asymptote and the hole. We start with making sure that we're working with a rational function. It says here that f of x needs to be represented as a ratio p of x divided by q of x. So in other words, we need to have ourselves a rational function. So the definition for rational function, if you'll recall, says that p of x and q of x both have to be polynomials. So that's still true here. And now statement 1 says that if x equals a is a 0 of q of x, but is not a 0 of p of x, then we can say the line x equals a is a vertical asymptote of f. So the first statement gives us the criteria for a vertical asymptote. The second statement says that if x equals a is a 0 of both q of x and p of x, then this ordered pair is going to represent a hole for f. So I'll mention that again. This represents a ordered pair. A hole is kind of like a point. It has to be represented on the graph by an x with the corresponding y, except this is going to be the absence of a point. It's going to be a hole. Now, what this is really getting at is what's going to happen whenever you plug in the a value for x. So the first statement says that it is a 0 of q of x, but is not a 0 of p of x. So for statement number 1, if you take a and you plug it into your function, then that means that you're going to have to plug in a into the numerator, and you're also going to have to plug in a into the denominator. That would be q of a. You have to plug it in everywhere. So if you plug it in everywhere and q ends up being 0, but p ends up being something that is not 0, some other number, then you're going to end up with a number divided by 0. This is called undefined. That's been our divide by 0 error since the first week or two of class. So anytime we get an undefined result when we plug something into the equation, that is representative of a vertical asymptote. Statement number 2 is supposed to give us the criteria for a hole. So again, we're supposed to be taking a and plugging it in to the equation. So that means we plug it into the top, plug it into the bottom, and if we plug it in and we end up getting 0 for p and for q, then we get something different. This is not called undefined. This is called indeterminate. And if you get an indeterminate result, then that means that you have a hole located in your graph. So we'll talk more about how to find all these things with the upcoming examples.